We are in module 3 discussing partial differential equations. Have a look at this function u is equal to f of x comma y comma and so on. Here u depends on more than one independent variable. In that case, if you want to see the change in u with respect to one variable x that is given by dou u by dou x, that represents partial differentiation of u with respect to x, that is found by differentiating this f with respect to x by treating remaining variables constants. So this is how the partial differentiation works. If we differentiate u with respect to y in the same lines, we will get dou u by dou y. And since these two are once again functions of x, y and so on, if we differentiate this with respect to x, that once again gives a partial differentiation of dou u by dou x. And if we differentiate this with respect to y, that gives partial differentiation of dou u by dou y, that is dou square u by dou y square. Now if you differentiate this with respect to y or this with respect to x, we will get dou square u by dou x dou y. These two are exactly the same. So now if we are talking about a partial differential equation which involves all these things, that is an equation involving dependent variable, independent variables and these partial derivatives. Let me see the definition of it. A differential equation which involves partial derivatives of a function of two or more variables. And in this chapter, we use u or z to represent dependent variable, or we can also call it as function or unknown. X and y to represent independent variables, we can also call it as known variables. Further, we use P, Q, R, S and T to represent these derivatives. And you people need to remember these notations because we can find the problems saying solve the partial differential equations in which instead of giving these derivatives, they can give these notations P, Q, R, S, T. So if you remember them, you can handle those problems in a better way. And at this chapter, we are mainly concentrating on three subtopics. One is formation of partial differential equation. Second one is solution of partial differential equation. Third one is application of this. Under formation of PDE, we are determining least order partial differential equation by eliminating either arbitrary constants or arbitrary functions depending on the problem. But it clearly says that whenever you solve the partial differential equation, that will either gives solution involving arbitrary constants or solution involving arbitrary functions. Now right now let me concentrate on how to form the partial differential equation by eliminating arbitrary constants. To understand that, let me consider this simple example. Z equal to ax plus by. So this is what I am supposed to do. Find dou z by dou x, dou z by dou y. So now we will be having three equations, that is the given equations and the two derivatives. Now use any of the operation like substitution, addition, subtraction, division or multiplication to have one equation which is free from these two arbitrary constants a and b. So now let me try to handle this. If I find dou z by dou x, that is given by a. If I find dou z by dou y, that just becomes b. Now I have found the value of a, b, I can substitute back in it. I am using a substitution method. So with that, my z equal to x into a is dou z by dou x, y into b is dou z by dou y. That is what I have written here. So this is one differential equation which is free from the arbitrary constants. So since we got the first order equation, so we are claiming that we have unique first order partial differential equation in this case. Have a look at this equation. Cz equal to ax plus by. It seems to be like an equation involving three arbitrary constants a, b, c. But you can note that if I divide throughout by c, this reduces to equation involving only two arbitrary constants. We can call a by c as one more constant, b by c as another constant. So now I can differentiate z with respect to x to have a by c, differentiate z with respect to y, that gives b by c. Now by substituting these two expressions back in equation 2, we get z equal to x into a by c is dou z by dou x, y into b by c is dou z by dou y. So this is the required partial differential equation in this case. So we can note that these two equations are exactly the same. The reason is these two solutions are not two different solutions, they are exactly the same. The same solution is expressed in different form. That's all. Now let me look into the next problem. Z equal to ax plus by plus c. So here it is made up of three constants. Now if I differentiate z with respect to x, we have a. Differentiate z with respect to y, we have b. But you can note that by using these three equations, we can't find one equation which is free from arbitrary constants because I don't know the value of c in this. So no option for us. We have to go for higher order partial differential equation to find the solution for this problem. Now differentiating this with respect to x gives dou square z by dou x square equal to 0. Is it free from arbitrary constants? Yes, we do not have ABC in it, so this represents one solution for our equation. If I differentiate same expression with respect to y, we get once again 0, so that also free from ABC, so that also serves as solution for this equation. Or if I differentiate this with respect to y, that gives dou square z by dou y square equal to 0. So this once again free from ABC, this also serves as solution for this equation. But in the exam, if the question is to find the partial differential equation by eliminating arbitrary constants ABC, don't write all the three answers. We are not interested in finding all possible differential equations here. If you write only one equation also, it is enough for us. We will give you full marks. So now have a look at this fourth example. Z equal to ax plus y. So if I differentiate z with respect to x, we get a, and a is the only arbitrary constant present in it. Substitute back in it, that gives z equal to dou z by dou x into x plus y. So this is a solution for us because this is free from the arbitrary constant a. But you can note that if you differentiate z with respect to y, that also serves as partial differential equation which is free from a. So which means for this case we have got two first order partial differential equation which are free from arbitrary constants. So now let me summarize what we learned now. So in the first problem, we have number of arbitrary constants are exactly same as number of independent variables. If that is the case, it is always possible to find unique first order partial differential equation. In the second problem, it is just giving us the clear idea that by looking at the number of constants present in the equation, so don't come to a conclusion that it is made up of more than two arbitrary constants. First try to reduce the number of arbitrary constants if it is possible. After doing that, if you claim that the number of arbitrary constants are exactly same as the number of independent variables, you are supposed to get unique partial differential equation there. So now, third problem says that if you have got number of arbitrary constants are more than number of independent variables, in that case you are not going to get first order partial differential equation, but you will get more than one second order partial differential equation, or it may be higher order equation if it contains some more arbitrary constants in it. Now if you come to the fourth problem, it says that if number of arbitrary constants are less than number of independent variables, we can find more than one first order partial differential equations. Now, so this is how any problem under this heading works. But still, let me concentrate, let me try to learn some more problems. Now in this example, it seems to be like equation involving more than two arbitrary constants. But it is made up of only two arbitrary constants a and b, because they have said it very clearly that alpha is a known constant. So we are not interested in eliminating alpha from this equation. Now if I differentiate this equation with respect to x, differentiation of z square is what? 2z dou z by dou x. Cot square is kept as it is. Differentiation of this becomes 2 times x minus a, and differentiation of y minus b whole square is 0. So that gives x minus a value for us. So here we find one arbitrary constant. I know x minus a, I can substitute this value in this place. And differentiating this equation with respect to y in the same lines, you will find y minus b value. Substitute that y minus b in this place. So now substitute with this substitution, you can find z square and cot power 4 is common, take it out, and that will cancel with the left hand side. We get only cot square in the left hand side. So this 1 by cot square becomes tan square alpha dou z by dou x whole square plus dou z by dou y whole square. So this is the required partial differential equation. You can note your final answer still carries alpha. It's fine for us. Have a look at this problem. Here z is equal to a log of b times y minus 1 divided by 1 minus 6. Whenever you have got log function, don't go for the differentiation directly. Try to simplify it first. Log of a by b is given by log a minus log b, and log of a into b is log a plus log b. So this expression gives log b plus log of y minus 1 divided by log of 1 minus 6. And this a is multiplied to all the three terms. Find dou z by dou x. These two are constants. Differentiation of 1 minus 6, that gives minus 1. So this is a by 1 minus 6. Differentiating this with respect to y gives a by y minus 1. Now observe this problem. We have three equations, but you can note that equation 1 is of no use for us because it contains b and we have not found the value of b here. What else can be done? We just divide one equation by the other equation. Otherwise, find the value of a in this, substitute here, or find the value of a in this, substitute here. You can note that by division method you have this expression a cancels, and by cross multiplication y minus 1 first comes here and that will be there with dou z by dou y. 1 minus x goes to the left hand side, that goes with dou z by dou x. So this is what the required partial differential equation for us. And please don't keep dou z by dou y or any dependent or independent variables in the denominator. So please keep all the variables and the derivatives in the numerator. If you find them, so please go for the cross multiplication, put it in the simple form. Now if we just look into this example, it's quite simple again. So differentiate this with respect to x. So 1 by az minus 1, a into differentiation of dou z by dou x, differentiation of 1 is 0, and differentiation of this is just 1. Now this is a by az minus 1 dou z by dou x, that is equal to 1. Differentiating this again with respect to y. So because of this you will get a, and here a by az minus 1 dou z by dou y, but a cancels here. We get dou z by dou y multiplied to 1 by az minus 1 equal to 1. So now it is just like the previous problem. Even in this case we have not found the value of b. So without b we can't make use of the given equation. Somehow I have to manage with these two equations only. So what we are supposed to do then? So even if I divide one equation by the other equation, the problem is not yet solved because a will still remains. So instead of that, this is what I am doing. I will find az minus 1 value from this and also a from that expression, like this. Az minus 1 is dou z by dou y, and the value of a is 1 is taken to the right hand side and 1 by z is multiplied. So substitute az minus 1 both in this. You are finding az minus 1 from this, substituting in this equation to have an equation which is free from a and b now. So go for the simplification. I've told you people that don't keep dou z by dou y or z in the denominator. Take them to the numerator by cross multiplication and bring them everything to the left hand side. And you can note, you can place your answer in terms of p, q, r, s, t. That is, so these are p, this is q, p into q plus p minus z into q equal to 0. Let me consider this equation now. Z equal to ax plus by plus cxy. You can note that it contains three constants and you just cannot reduce it into reduce anything lesser than that. Even if you divide by c, you will get 1 by c, a by c, b by c, three constants once again. So no option. So we need to go for the higher order in this case. When you differentiate with respect to x, you will get a plus cy. With respect to y is differentiated, so b will remains here and cx is constant, differentiation of y gives 1. Now from these three equations, definitely it is not possible to find a differential equation which is free from abc. go for higher order. If you differentiate this with respect to x, there is no x here, it gives 0. There is one possible solution for us. If you differentiate this with respect to y, there is no y here, so this also serves as one more possible solution. Now you can find one more possible solution here. If you differentiate this with respect to y or this with respect to x, you will get c, because with respect to y is differentiated, differentiation of a becomes 0, c into differentiation of y with respect to y gives c. Now c value is known, use it in equation 2 and 3 and find the value of a and b. Now use a value, b value and c value in equation 1 and go for the simplification. A, b, c substituted. On simplification, you will end up with this answer. So this have any problem under this partial differential equation or formation of partial differential equation by eliminating arbitrary constants works. So thank you all. Please go through